placed in the dimension. I can actually select it and just drag it out as well to whatever length I want as well. That's another option in there that we can do. But I've still, obviously on this rectangle, if I drag that, I've still got a level of freedom on the height there because there's no constraint in there. So what I could do is I could just stick one in there as well. So I'll just put one on that object, drag it out there, and just type in 500. Okay. Other stuff that we'll have a look at, let's just have a look at the properties of this object because they're very different to standard dimensions. You can see it's a much more cut down version because it's a constraint. And we can select and put in the figures in here as well, and that will constrain it. And then you've got your option here with your facility here to change it to an annotational one. Okay, so I'll flick it to an annotational one. And now you'll see you've got all the information in there that you're used to seeing in your dimensions. And then, of course, if I zoom, it's going to act in the same way that you would expect an annotational dimension to work on. It's still got the padlock. It still allows me to change it.
Well, to be fair, Ian, I think any idiot can do that, including me. So
well, let's see, shall we?
Right, so you had 4 lines. Yeah, so let's draw something that resembles a rectangle. Track down from there. Okay, so there's my rectangle. That's easy enough. Parametric ribbon, linear dimension, object. Yes, look at this. There we go. There's my dimension. Let's change that to 2 meters. Wait, oh.
Yeah,
I've done something wrong, mate.
No, you haven't. It's done exactly what Simon's asked it to do. What he said is that top line I want to be constrained by 2 meters. And what we need to get it to do what I've done is we need geometric constraints. So we need to constrain the geometry. Let me explain. The first thing is if he ties up all the corners. So if I was to draw a line here, like, oh, hang on, press enter instead of hash would help. A line like so, okay? All up here is the geometric ones. If I use a coincident constraint and I make that point and that point coincident, watch the second line, it's now going to that point is going to remain in the same place. If I move this line, that constraint is going to force the other line to move. Okay? It's a coincident point. So you need some coincidences.
Right, so, okay, here's my coincidence. Let's put the corners together. Notice when I do it, I get a little blue dot just to tell me that it's actually happening. We're getting that information, so let's do the same on that one as well. And all my 4 corners. And this corner as well. Okay, so there we go. Select this now, let's see what happens. Oh, look at that, that's really weird and spooky, does that, Ian?
Yeah.
What's going on here?
Yeah, what you need now is you could do with a right angle. So we've got constraints that force right angles. So let me show you. If I put a perpendicular constraint between that line and that line, watch what happens. It is now at right angles, and I can't stop that being at right angles. So if I rotate it round, then obviously the other line's going to have to rotate around with it. Like so.
Fair enough. So let's put a perpendicular one in there. We go. I'll make this one perpendicular with that one. Right, now Ian, I know I could do it on the other corners as well, but anything else I can do different?
Yeah, you could use parallel. I'll just stick a line in here, like so. Okay. And what we can do here is we can pop a parallel constraint in. So I'm going to make that line and that line parallel. You can see it's snapped to the parallel. So if I move this line here, the other line's going to move and remain parallel. So I've got 3 constraints on there. So it's forcing the other line to rotate around the point that it's coincident with, and the other line will follow it in terms of it to remain parallel.
Cool, let's use that one. There's the parallel one. Choose my first line, choose my second line. Job done. I know I could do a top and bottom in. What else can I do instead of parallel?
We've got an equals constraint as well. So if I use the equals one, so I'm going to make that line and that line equal. Watch what happens to the second line. It should become equal to the first one. So there it is. They're now equal. Excuse me. If I make that line longer, the other one will go longer. Yeah. So we can see that they are remaining equal.
Okay. There's my equal one. Let's make the top and the bottom one equal. Okay, so yeah, it's looking a bit more like the rectangle you had. But I've noticed now if I move this, instead of it all going all weird shaped, I can actually now rotate it. Is there anything I can do to stop it sort of rotating almost?
Absolutely, yeah, here we go. We've got a horizontal one. It's fairly obvious what's going to happen here, yeah. If I force that line to be horizontal, it's going to go horizontal. Obviously that line's got to be parallel, so that's gone horizontal. Obviously that line has to be perpendicular, so that's gone vertical. So imagine if I move this line from here now, if I try and rotate around that point, what's going to happen? Well, because it has to stay horizontal, it's now making the whole object move as one object.
Okay, so there's my horizontal, we'll put one on the bottom, and I now have my rectangle. Now hopefully, touch wood, now I want to change this to 2 metres. Working, just what we want. I've still got that degree of freedom that Ian had when he first did his rectangle, so we'll just put another dimension in on our vertical side here for the height, and we'll change that one to height. Now we can take this further. Notice I've renamed it to height. It's now got a name associated to it. And I can come into the width as well, and we can change that to width. So these dimensions have almost got parameters and words. So what we can now start to do is we can start to maybe put equations in and force dimensions to be an equation to another one. So for instance, this one here, the height, let's change the height so that it's the width divided by 2. So width divided by 2. Okay. Hopefully now, if I change this to 2 metres, as you can see, that's automatically changed as well. Now we don't know what this is at the moment, it's just width divided by 2. I've got to calculate the width to work out what the height is. So we can actually change that. If I just drop this little arrow down here, and the settings I can change to just save a value. So we'll actually get the physical value in there. It still works on the equation, so if I change this to, I don't know, 1500, it's going to drop to 750. So it's fully parametric.
Yeah. Okay, so we've shown you all these different constraints, but obviously we want to show you smarter and faster and more productive ways of doing these type of things. So we've got a drawing here that Simon, you could show us.
Yeah, on this drawing what's happened is it's a drawing that I received from our technical director. He struggles sometimes, that's Paul lad. But it's a universal beam, and I'm sure you all looked at that and went, that's a universal beam. But what we can do is we can use this auto constraint function. Now if I use the auto constraint and just go to the settings, it's going to automatically assign these constraints in one pass. It's going to make associations between certain lines that are close to each other and automatically assign them. So all we do is we simply draw a box, select the objects we want to auto constrain, press enter, and notice it's automatically assigned a boatload of constraints. If you want to see where these constraints are being assigned to, if like for instance we've got a parallel one here, notice it's highlighting the top left hand flange. This bottom right hand flange is also parallel with the other flange as well. So Ian, which other constraints do you think we could use to try and improve this I-beam?
Okay, I reckon you need to make them flange edges vertical first, and we've already shown you the horizontal one. It's obviously the same, but vertical.
No problem. Select that one, make it vertical, and because these are parallel, it's automatically adjusted them. Anything else, Ian?
Yeah, you can improve the arcs with a tangent one. I've got to be very careful here because it gets very close to the word genital, and that's what I said yesterday, and everybody laughed at me. So, if you want
the tangential constraint?
If you want to make your arcs tangential, not tangential, with your flanges there, let me explain. Tangent one on my screen here. If I just draw myself a circle, like so, and a line, like so, okay, we can use the tangent one here, and we can make that circle and that line always constrained. So if I move the line, what's going to happen to the circle? It's going to move with it. Okay? It's going to remain... Oh, I broke it. There we go. Is that just the screen? There we are. It's always going to remain touching it as well. Okay, so that's a tangent. So you could do that with your arcs.
No problem. As you see, it's automatically, it's already assigned some and it's associated these, but it's missed this one because the lines were too far out of true. It couldn't work out that they were going to be tangential. So we'll use our tangent constraint and we will assign it to there, and we'll do the same on this line as well. So they're now nice and smooth on an arc. So what else can we do, Ian?
Okay, we could do with making your flanges collinear. Okay, let me explain. I'll use this drawing here, spin that around a little bit to there. Okay, if I draw myself another line here, and I use the collinear one, which is that one there, what's going to happen, as soon as I click on that second line, Yeah, it's not rocket science. It's going to go